All right, we're going to take a look at this problem here. They want us to calculate the area of the shaded region here, so the area of this triangle here. First thing we want to do when we tackle this problem, let's go ahead and try to find out some more information and use the radius of the circle being 2, see what we can do to kind of break this up and find out more about this picture here. So I'm going to go ahead and slice this square in half here. And right away, I know the measure from here to here must be 45 degrees, right? The whole thing must be 45 degrees. I'm going to let this be theta, and I'm going to define this angle here must therefore be 45 minus theta. Now, we know the radius of my circle here is 2, and that's going to be for everywhere, in particular here. So I can go ahead, I'm going to drop this down. That's going to meet at 90 degrees. I know this is 2. And likewise, I know that this is also going to be 2. So I'm going to let this be h. Let's call this h1. And using Pythagorean theorem, I'll find the length, at least I get the length from here to here. So going ahead and doing Pythagorean theorem, I end up getting that the length from here to here is going to be 2 root 2. So I've got another right angle triangle here. I'd like to be able to use this right angle triangle. I know, like we just discussed here, I know that this is 2, so that's good. I know this length. I do not have this length here, but I can find that length because I know this is 2 root 2, and I know that this rectangle, or square I should say, is 8 by 8. So I can do Pythagorean theorem on this diagonal cut we've made here. So doing Pythagorean theorem here, we're going to get h. H is going to represent the entire hypotenuse here. And again, I'm referencing this triangle. So we've got this right triangle here. That h squared will be equal 8 squared plus 8 squared, in which case h squared is going to be equal 2 times h squared. And taking my square root, I end up getting here 8 root 2. That's going to represent the length of the entire diagonal cut. And then I know that this portion right here is 2 root 2. So subtracting this up here, I actually know that the length from here to here will be 6 root 2. And again, I got that by subtracting those two. So now I've got two legs of this. I got the one leg of the triangle, the hypotenuse. I can go ahead and find this leg of the triangle here. Again, using Pythagorean theorem, I'll label this with an a. I know that a squared plus 2 squared must equal 6 root 2 quantity squared. And we can go ahead and solve for this here. So this becomes 36 times 2 minus 4. I get a squared is 68. Taking my square root, I get root of 68, which is also 2 root 17. So I now know this leg right here will be 2 root 17. So again, trying to find out as much as we can of this shape here. So now, if you take a look, I want to calculate the area of this triangle. And the height I know that's 8. I just need to find this base here. But this base, I have a right angle triangle. If I label this with an x, I know this is 8. And I now know that this is going to be the tan of 45 minus theta. So I know that if we kind of take a look over here, I know the tan of 45 minus theta must equal x, my opposite, over my adjacent. So I actually know that x is going to equal 8 tan of 45 minus theta. But you'll notice here that can be represented as 8. And if you use your compound angle formulas, you know this will be the tan of 45 minus tan of theta over 1 plus tan 45 tan theta. So I can use, once I have this, I can multiply this by 8, divide by 2, and I can have the area of this triangle here shaded in blue. So I've got a ton of information on here. If I just need to find what the tan of theta is equal to, but I have a right angle triangle right here, right? And I know the length of all these legs now. So right away we know, let's see if I can squeeze this on this page here. I know the tan of theta is going to equal, again, this is my theta, it will equal the opposite over my adjacent. So this will actually end up being 1 over the root of 17. So I know that the tan of theta is 1 over the root of 17. So therefore I can go to my equation here. And I know the tan of 45 is 1. So continuing this on here, I have x equals 8. This would be 1 minus the 1 over the root of 17 divided by 1 plus 1 over the root of 17. So now I know that the x value is this number here. We're going to work with that. So to finish this off here, you're going to end up taking your x value and multiplied by your 8 and then dividing by 2. Let's go ahead and do that computation below. So the area of the triangle will be base times height divided by 2. My base I know is equal to 8 times 1 minus 1 over the root of 17 divided by 1 plus 1 over the root of 17. And then the height we know is 8, and we're dividing that by 2. So we want to essentially do this calculation here. This will end up equaling 32 times 1 minus the root of 17 over 1 plus the root of 17. And if we punch this in our calculator, we end up getting here approximately 19.51 as the area of the triangle shaded in blue. If you are looking for an exact value, we can go ahead and rationalize the denominator on this. So if you want to get an exact value out of this, you can go ahead and rewrite this as root 17 minus 1 over the root of 17 plus 1. Then I can multiply the top and bottom of this by root 17 minus 1. And this ends up being 32 times, in the numerator here, we end up getting 17 minus 2 root 17 plus 1 all over 17 minus 1. And this ends up being here 32 times 18 minus 2 root 17 all over 16. And we end up getting here 2 times 18 minus 2 root 17. There's another 2 trapped up in there. So this is going to end up being 4 times 9 root 17. And again, if you're looking to simplify this completely and sort of express this as an exact value, you can write this area of this blue triangle as 4 times 9 minus root 17. All right, thank you.